Hi, so assignment 3 builds up on assignment 2, where we are trying to make the efficiency of our application better, improve the efficiency. So what we did in 2 was to introduce two sorts because we still wanted the database to be sorted according to chart position, so we could pick out the top 10 songs and be able to easily insert and remove according to a number that is the chart position. But we wanted to improve our search, so we made a copy of the database and we sorted that back up using a selection sort by title, and then we searched using binary search. In this assignment, we are going to introduce recursion, and we are going to introduce a new sort. Our first need is, now that we have two sorts, we need to make our sorting more efficient. Because as you see, doing selection sort 2 times can be quite expensive. So we would like to select, or we would like to use a sort that sorts by position, but it's much faster than selection sort. And the one that we are going to use is the Radix Sort. Now, I would like you to view your Zybooks, and the algorithm for the Radix Sort is given right here, and you're free to use this algorithm, and it has a very good description and exercise on how this works. We are lucky because we are sorting on the basis of an integer, and Radix Sort does exactly that. It can sort very quickly using buckets on the basis of integer. And then you will have a chance to observe how much more efficient your sorting has gotten. The other thing that the other algorithm is the recursive merge sort. So having replaced the first selection sort with Radix, we are going to look at our second selection sort that we were doing on the backup and see how we can improve that. And we are going to use the merge sort. Now, in order to use merge sort, you would need to be comfortable with recursion, and I have posted a video lecture on recursion overview. So please feel free to look at that and read the resources in your Zybooks on recursive algorithms. So recursive definitions and recursive algorithms is there in your Zybook. So please be sure to practice that before you start the assignment. So then our task now, so going back to notes, our task is to replace the first selection sort with Radix Sort, replace the second selection sort with the recursive merge sort, and then also what we are going to do is a couple of things which are here in our assignment. Replace the binary search, the iterative binary search, with the recursive binary search. So these are the 3 primary things that we will do, and then you will observe the output as usual from the template that's given to you. The assignment 3 template is given to you, and all of the song.cpp.h, the vector ADT, all of these are by now familiar and have been filled with your code from previous assignments. So the output that is expected in this case, you see the Radix Sort is what you're going to be doing first. And then we are going to do the merge sort after this. So let me just show you how the output changes. So the merge sort has been done. Now you will notice an additional functor, which is called chart pos. Why do we need an additional functor? We need it because when we do Radix Sort, we are not actually comparing two song objects, but we would like to get the chart position because we would like to sort it by chart position. So in order to go down that one level into the song class and extract the chart position, we need a functor to pass to our database, and then that database is going to use that functor to actually extract the chart position from the song. So we can, if you have done your adjust insert and your adjust delete, then you're good. You can simply, as you can see here, after creating the database, you're going to sort the database according to the Radix sort. Keep all the actions of insert, delete, and all of that exactly the same. And then we're going to come back here, create the backup, and then do a merge sort, and then do a binary search, recursive binary search for the title, right? All right.